Hello and welcome back, and in this video we're going to be learning about integrating core image in SwiftUI. SwiftUI can integrate seamlessly with other Apple frameworks. It is designed to work well with existing frameworks like core image, core data, or combine. By integrating these powerful frameworks, we can take advantage of their capabilities. So let's go ahead and understand what does it take basically to integrate core image into SwiftUI. Now, as you might know, core image is basically a powerful framework provided by Apple for high performance image processing. It is available on iOS, macOS, watchOS, tvOS, and visionOS. Core image allows us to apply various built-in image filters and also allows us to create custom filters to manipulate images efficiently. Let's go ahead and start by creating a new class for image processing. We're going to call this class core image example, and this will be an observable class. So let's go ahead and import all the necessary frameworks as well. For simplicity, I'm going to create that file right here, or that class right here, but you might want to create this in a separate file. So we're going to start with an import for core image. We are also going to import core image.ci filter built-ins. Now, CI filter built-ins provide a convenient way to fetch all the filters that are already created, filter factory classes that are already created for us, so we can actually use them with simplicity and in Swift manner. Okay, we are also going to import observation framework because we want to make this class observable. Next thing we're going to do is we're going to start with observable macro. And then we're going to create our final class. This class will not be inherited by anyone else, so that's why we're going to make it final so its compilation is fast. We're going to name this core image example. And then we're going to get started. So here what we are doing is we are importing core image framework for image processing and observation framework so we can decorate the class with observable macro. Now, an observable macro is basically used to automatically track changes to the properties within a struct or a class. Now, this notifies the dependent views when something changes so they can update themselves. Now, in this class, we will have three properties. There's going to be an image, which is going to be an image object to store and publish output once the image manipulation operations are complete. There's going to be a context, which is going to be a CI context object. Now, CI context is a crucial class in core image that acts as an intermediary between core image filter and the underlying graphics system. It provides the necessary context for rendering image processing results and performing image analysis. Third property we're going to create is going to be the current filter. It is going to be a CI filter object. Now, the CI filter object is basically the image processor within core image framework, and it takes one or more input for the image and manipulate them to produce a new output image. So let's go ahead and create our image. What we're going to do is we're going to initialize this image property with image that is already stored in our image resources or assets catalog. Next, we're going to create context. This context is going to be CI context object, and we're going to have current filter. And this current filter is going to be the CI filter instance. Next, we will create functions to apply filters to the input image. We will use an image stored in asset catalog for these functions. Now, first image filter will be the Savia filter. And the Savia filter is a built-in filter that transforms an image into monochromatic brown tone, giving a vintage or antique appearance. it is a popular choice for achieving the nostalgic look. Okay, so we are going to create a function apply Savia Filter. We're going to take an input image as the parameter, input parameter, and this is going to be of image resource type. It can be your image type if you are supplying an image, a raw image, or it could be any type like data, which can be a binary data for the image representation. In this case, we're going to be using image that is stored in assets catalog. That's why we are using image resource. Next thing we're going to do is we're going to assign the sepia tone to CI filter. So we're going to take our current filter and we are going to use the convenience method, that is convenient factory method, that is created inside the CI filter built-ins to fetch the sepia tone. And this is going to return basically an initialized or an object of sepia tone CI filter. Okay, now CI filter operates on the image data, and it processes basically on the image. So the input image needs to be in a format that it can understand. This is where CI image comes into play. It provides a standardized representation of image data that CI filter can easily manipulate. So what we're going to do is we're going to convert our image into CI image. And the easiest way to convert an image into CI image is by using CI image initializer that takes UI image as the input. So we're going to take our UI image, initialize UI image with the image resource, and we're going to pass DT into that. We have two examples here. We have DT and a Taj Mahal. So we're going to see both examples one by one. Okay, so let's go ahead and try with the resource DT. Okay, that's DevTechie's logo. And we're going to use that and convert that image, fetch that image as UI image and convert it into core image format so core image filter can operate on that. Now CI filter sepia tone takes two parameters that we need to set for this filter. First is the input image, which is a CI image, and this is basically the image on which the sepia tone effect will be applied, and this is specified using KCI input image key. Okay, so let's go ahead and set that. So we're gonna reach out to our current filter and we are going to set value for, and we are going to set the input image. So input image is going to be CI image, and it's defined under the key KCI input image key. Okay, now we are not using any of the convenience that are provided by the CI filter built in this particular instance that we get. The reason is that this, for some odd reason, still the most deterministic way to set these values, and I have observed that many times when you are using CI filter built-ins and use the properties to set these input images, they actually go wrong. So for that reason, and to be safe, we are going to be using the old way of setting the value by setting a value for the key in these filters. Okay, so now what we're going to do is we're going to set the next parameter. So next parameter is the input intensity. Now the intensity is basically how much of the sepia effect that we want to apply. Now this is specified by CI input intensity key, and the value ranges from 0.0, which means no effect, to 1.0, that means full effect, full sepia tone. Okay, the default value is 1. That means if you don't set anything, you're gonna get a complete sepia toned brown color image. Okay, So let's go ahead and set this. So we're gonna take our current image filter, set value again, and this time we're gonna set 50% for the sepia tone, and the key is going to be KCI intensity key, input intensity key. Okay, now since we will be creating two filters, it makes sense to combine the image processing code into a separate function. So let's create a function called process image, which is going to be a function to retrieve the processed image from current core image filter, and we're going to convert this image into CG image so we can use it inside the image view. Okay, so let's go ahead and create another function. We're going to call this function process image, and this function is basically first going to fetch the output image, and output image is what we're going to get from the current filter.output image. So once the core image filters are done manipulating images, they actually return the output in output image parameter or output image property. So we are going to simply try to extract that. If we can't, there is no point moving forward from here, so we're going to return from here. Next thing we want to do is we want to try to convert this output image into a CG image. And this is going to come from context.create CG image from image, and from image takes CI image as an input, and we are getting that in the form of output image, so we're going to supply that. And the from CG rect is basically how big the image is going to be, and that information we can extract from the extent property of the core image. Okay, if we are able to fetch this information and convert the image into a CG image, then it's great. Otherwise we're going to return from here. Second last thing we're going to do is we're going to convert our image into UI image by using UI image overload that takes a CG image as the input parameter and converts an image into UI image. It converts a CG image, core graphics image, into UI image, and then we're going to convert finally into our SwiftUI image view using the image overload that takes the UI image, and we're going to pass our UI image into this. Now, before we move forward, basically on building the SwiftUI view, we'll basically add another core image filter, and this one is called CI Pixelate. Okay, actually, you know what? Let's try this first filter out before we build that next core image filter. Okay, so let's go into our example, and what we're gonna do is we're gonna first initialize our core image example. So core image example, and since we made this class observable, we're gonna basically create a state property out of it, so we can observe the changes as they're happening on basically within that class. Okay, so whatever is getting published, we're gonna be able to use it. Okay, so we're gonna create a VStack, and inside the VStack we're gonna call our core image example. We're going to fetch this image instance, make it resizable, make sure that it is scaled to fit, and let's go ahead and set the frame with height as 200 points. This should show a image here, the FTK logo in this case, and then we're going to have an Hstack. Hstack is going to host basically two buttons. So there's going to be a button with an action, and this action is going to call our core image example, apply Savia Filter, and we're going to pass the DT as the image. Okay, now let's go ahead and set the label for this guy, and the label is going to be text Savia Filter. let's go ahead and set the button style for the entire Hstack. And we know that this Hstack is only going to host buttons, so we're going to say button style border prominent. Okay, now once we have basically set the action on the on this button, we are ready to use this. So let's go ahead and apply the sepia tone and see if we can actually get the sepia tone. We're not going to get it because we are not calling the process image right here. Okay, so once we have called process image, we can apply the sepia tone, and there we go. We can see that we have our image basically converted into sepia tone. Okay, now let's go ahead and increase the intensity so you can see it in much more detail how when the image turns into brown. Okay, so as you can see, it is very fast, and it actually, the filter itself is a little bit slow on the simulator. On the devices is very fast. Okay, so let's go ahead and try another image example. So I'm gonna change the image reference here to Taj Mahal, and I'm gonna change this to here as well, Taj Mahal. Okay, and we have that image inside the assets folder. So what we should see is basically an image for Taj Mahal, and then we'll be able to apply the sepia tone on that image as well. So that'll give you another example of like, you know, how the sepia tone actually looks on different images. All right, so our image is loaded. Let's go ahead and apply the filter. And I believe we need to parameterize this. Let's go ahead and fix it for now, and we'll apply the sepia tone, and then we'll come back and fix all the input parameters. So as you can see that we have basically applied the sepia tone, and it is successfully applied and changed the tone of the photo. Okay, now let's go ahead and create our next filter. Okay, so we're gonna create the filter. It is called CI Pixelate, and basically this CI Pixelate pixelates the image, or adds the pixelation effect to the image. Okay, it takes three input image, obviously, an input image that it's going to operate on, input center, basically the center point for the pixelation effect, and this determines the center for pixelation, and the value is taken in the form of CI vector. And CI vector is basically a coordinate in image's coordinate space. The default value is CI vector x 150 and y 150, and we can change that. Now input scale is another parameter, and the scale parameter is basically scale for the pixelation effect, and this controls the size of the pixelation cell. And we're going to see, like, you know, by applying different values to the pixelation. So let's go ahead and create a function here. Apply Pixelate filter. We're gonna get it input image resource, and then we're gonna first create our CI image from an image, UI image. Resource is going to be the input image, and then we're gonna take our current filter. And this is what we should have done here. Instead of calling this, we should have called input image. There we go. We're gonna take our current filter. We're gonna basically first initialize the CI filter dot pixelate as the instance. So we're gonna reinitialize the current filter value and turn it into an instance of Pixelate core image filter. And then we're gonna set the current filter dot set value, and we're gonna set the first value as CI image. This is gonna be the input key, so k input image key. Then we're gonna set the value for vector, so we're gonna say CI vector, and this is basically gonna be the center point, and this takes X and Y value. So we're gonna say the center for the pixelation is gonna be at 100, 100, and KCI center key is the key, and then we're gonna have, last but not the least, the scale. Okay, and K input scale key is the key. All right, now we don't want to forget calling the process image, just like we did last time. And let's go ahead and create another button here, and this button is going to be called Pixelation. Okay, so Pixelation filter, and we're gonna make sure that we actually call, and I think I have misspelled this, so let's go ahead and change it to X, Pixelate, change it to X, there we go. All right, so we have like two filters, one is sepia tone and another one is the pixelation. Let's go ahead and try the pixelation, and you're gonna see this image basically pixelate, and pixelation is not that much, so that's why you're not seeing that much of a difference. So let's go ahead and set this value to, like, you know, a higher number. Okay, so we're gonna set it to 50, and let's go ahead and apply pixelation. There we go. So now you can see the pixelation effect a little bit more clearly, where your image is now pixelated. Now you can combine these CI filter with, like, you know, a few more options, and there is a website that Apple actually provides which actually shows you how, like, you know, what kind of other filters and what their input values are available. Okay, so the website itself is developer.apple.com library, and this is basically a graphics image reference, or if you Google core image filter reference, you will actually be able to find it. Now let's go ahead and take a look at the filters that we applied. So we applied sepia. Instead of using this, let's use page sepia. There we go, sepia tone. And you can see that you have sepia tone applied on these two images, and it shows, like, you know, what the input key is and what is the input intensity. Let's go ahead and check out the pixelation as well. So pixelate, there are two types, CI hexagonal pixelate and CI pixelate. This is the one that we use. So let's go ahead and try this one out, and there we go. You can see that we have input image and your center, which is, like, you know, CI vector, input scale, which default value is 8, and you can see the pixelation on the image itself here. Okay, and also shows, like, you know, basically when it became available and what is the support. So there are, like, you know, a few that I would actually highly recommend you to check out and see how they work. Some of them actually are very useful in other image processing. So combining these filters creates, like, you know, builds up a pipeline that you can use for further image processing. For example, the Gaussian blur is quite popular, and there are, like, you know, a few others as well. Okay, so I hope you found this video informative, and this is it for this video. Thank you so much for watching, and I will see you guys in another video.